Let's dive right into this. Welcome to today's explainer, the floating egg mystery. Today, we're taking a single, classic visual puzzle, a standard tabletop physics demonstration, and we're going to completely unravel the invisible mechanics making it happen. So, let's look past the surface and figure out the actual physical laws at play here. Take a really close look at this setup. We've got two completely identical clear glass tumblers resting on a ledge. Both are filled with what looks like a clear liquid, and there's an ordinary, uncracked white egg in each one. To our eyes, literally everything is a constant here. Well, except for one glaring detail. The behavior of the eggs is radically different. Over on the left, the egg rests heavily at the very bottom. But on the right, the exact same type of egg is just hovering, perfectly suspended at the surface of the liquid. It's wild. And that observation brings us right to the core of our investigation today. Why does one egg sink like a stone while the exact same type of egg just floats? I mean, when an outcome changes, a variable has to have changed, right? Things just don't happen randomly. But visually, that variable is completely hidden from us. The environment, the gravity pulling down on both glasses, the eggs themselves, they're all absolutely constant. So what's the secret? To find out, we really have to look past the obvious similarities and start questioning the invisible forces at play. So setting this up as a comparative experiment, we have our control on the left, a sinking egg in a clear liquid, and our anomaly on the right, a floating egg in a clear liquid. Now, if the glasses and the eggs are constant, we're left with literally only one possible suspect, and that's the liquid itself. Even though the liquid on the right looks exactly identical to the one on the left, it's clear, it's colorless, it reflects light the exact same way, it holds a hidden variable. Its physical properties have been fundamentally altered in a way our eyes simply cannot detect. All right, so the absolute crucial concept here is density. Density is basically the measure of how compact the mass in a substance or object is. It's the invisible referee deciding the fate of our eggs. To really wrap your head around this, think about packing a suitcase. The suitcase itself represents a fixed volume, right? If you loosely fold a few t-shirts and drop them in, it has low mass in that space, and therefore it has low density. But if you take that exact same suitcase and cram in 5 heavy textbooks and a week's worth of winter coats, well, you haven't changed the volume, but you have massively increased the mass. You've